Today we will discuss how to write JC form for a matrix when a minimal polynomial and characteristic polynomial are given. Okay, so first we will learn about Jordan block. So what is Jordan block? So a square bidiagonal matrix is said to be Jordan block if all its diagonal entries are equal. Okay, means it is a bidiagonal matrix. Okay, and the element on the diagonal are equal. Okay, so if we see uh, example of the Jordan block, it is like this, and its size is 3. So order of this Jordan block is 3. Okay, and diagonal element are equal like 2, 2, or 2, and the lower part for of the diagonal is 0, and for of the above on the diagonal it is 1, 1, and other elements are 0. Okay, so this is a Jordan block, and Jordan block of order 4 will be the 4 cross 4 matrix having all the elements are same on the diagonal, and 1, 1, 1 will be of the above the diagonal, and all other elements are 0. Okay, so now definition of Jordan canonical form. So it is a Jordan, it is a block diagonal matrix. Okay, so it is a block matrix in which the blocks are Jordan block. Okay, and it is on the diagonal in which blocks are Jordan blocks. Okay, and the diagonal, it is on the diagonal in which eigenvalues are on the main diagonal. Okay, so if we see the example of the Jordan canonical form, so this is the example of the Jordan canonical form for some matrix. Okay, so here 1, 1, and 3 are the eigenvalues, and it is a 2 cross 2, one Jordan block, and 1 cross 1 is the another Jordan block. Okay, so here 1, 1 is the eigenvalue corresponding to uh, 2 cross 2 Jordan block, and 3 is the eigenvalue corresponding to 1 cross 1 Jordan block. Okay, so here we have used two Jordan blocks. One is of size 2 cross 2 and another is of size 3, sorry, 1. So how we will write a Jordan canonical form for a given matrix, we will know. Okay, so we have given CAX product I vary from 1 to k x minus alpha I to the power ni. Obviously, sum of the powers on the characteristic polynomial is equal to the size of the matrix. Okay, for which this is the CX. And minimal polynomial is product I vary from 1 to k x minus alpha I to the power mi. And sum of mi will be less than equal to ni. Okay, obviously mi will be less than equal to ni. So we have given CAX and MAX, and we need to write a Jordan canonical form for the given matrix A. Okay, so first property of the Jordan canonical form we will use is that in the JC form for each alpha I, what is alpha I? Alpha I is the eigenvalue corresponding to the matrix A. Okay, x minus alpha I to the power mi. So alpha I will be eigenvalue corresponding to A. So for each alpha I, there is at least one block of order mi, at least one block of order mi. So mi is the power corresponding to x minus alpha I in the minimal polynomial. Okay, so there should be at least one block of order mi, and other block and other blocks corresponding to alpha I have order less than or equal to mi. So at least one block for this alpha I. should be equal to of order mi, and other blocks will be of size less than equal to mi. Okay, and second property is that sum of the order of all the Jordan blocks corresponding to alpha I equal to ni. This one, so all the Jordan blocks corresponding to this alpha I will be equal to ni. Is one will be of size mi and other will be of size less than equal to mi, and all the order, sum of all the orders, okay, should be equal to ni. What is ni? Ni is the power corresponding to x minus alpha I. Okay, and number of Jordan blocks corresponding to alpha I is equal to geometric multiplicity of alpha I. Now, how many Jordan blocks should we make corresponding to alpha I? So it should be equal to the geometric multiplicity corresponding to alpha I. So we don't need to find out geometric multiplicity. We will use this property and we can find a Jordan canonical form. And fourth, if transformation is known, then GC form is uniquely determined. If everything, geometric multiplicity, algebraic multiplicity, minimal polynomial, characteristic polynomial, everything is known, then we can write the matrix eh, of the GC form. It will be unique GC form. Now, example of a matrix when CX is given and MX given. So we need to write GC form for this matrix A. So for this matrix A, we have x minus 2 to the power cube multiplied by x minus 1. This is a characteristic polynomial. And the minimal polynomial is x minus 2 square x minus 1. Okay, so it may not be in actual, but we have taken some example. So n1 equal to 3 because x minus 2 to the power 3, and n2 equal to 1. Okay, here m1 equal to 2 and m2 equal to 1. So by the above rule, alpha 2 for alpha equal to 2, here eigenvalues are 2 and 1. So corresponding to this eigenvalue, at least one block of the Jordan canonical form of size should equal to 2, because the power in on the minimal polynomial corresponding to alpha equal to 2. So one block of size should be 2 and other block should be of size less than equal to 2. So here one block of size 2 is used and other block of size less than equal to 2, and for m2 equal to 1, because of eigenvalue corresponding to 1, we have only one block because at least one block should be of size 1 and there is no possibilities for size less than equal to 1. Okay, so using these properties we can form Jordan canonical form, which is 2 1 0 2 0 0 2 0, one block of size 2, one block of size 1 corresponding to alpha equal to 2, and one block of size 1. So we have 4 cross 4 matrix which is JC form, and the non-zero elements are the 2 1 2 2 and 1. So thank you.